All right, it should be streaming now. Okay, good afternoon, everybody. And yeah. Okay, guys, grade 11 and my grade 12 that are in class. We are looking at acid and base, and everything we look at here in grade 11 will be tested. So for grade 12, it's more of a revision back to basics. And for grade 11, it's a build up. And if I were you and I'm in grade 11, I will keep this note because nothing changes. We are doing the exact thing that we need to do in grade 12. Just 1 second. I'm looking for my YouTube live so I can monitor questions and all that matter. Just a moment. Okay, so guys, with chemistry, usually what happens is there's a lot of definitions. There is a whole lot of definitions. So I'm going to be defining. Please don't wait for exam. Don't wait for exams before you learn all those definitions. Let's get into the habit of doing our definitions right from the beginning. Right from the beginning. Just 1 second. I'm just trying to get to my YouTube live here. One moment. Can't seem to get hold of my YouTube live on my monitor so I can see all the questions. All right, there we go. Okay. So those of you on YouTube, we can follow right now. And yep, we can also see your questions if there is any as we go on. All right, quickly, guys, acid and base. Now, like we said, very important is our definition. So we're going to run through a number of concepts tonight. First is, let's look at the definition of acid and base. Definition. Please, guys, if you can keep your mics muted. There's a whole lot of noise there, please, so that we can have a very quiet class. Maza, I don't know, there's kind of some noise in your background. Okay, now when we look at acid and base, there are two definitions, two criteria of definition. Number one, we are going to look at the Lowry-Bronsted, using the Lowry-Bronsted concept of definition. Examiners are going to be very, very clear on what they need. What is an acid? An acid is a proton. Now, what is a proton? It's a hydrogen ion, a proton donor. So whenever we say proton, the formula is H+. It's a hydrogen ion, and a base is a proton acceptor. Remember what my proton is? My proton is the hydrogen ion. An acid is a proton donor. And as I'm going on, I'm going to quickly show you how to start writing those formulas. And a base is a proton what? Acceptor. That's our first definition. quickly, what happens when an acid donates a proton? I just want to quickly look at some equations here with you. Look at this. For example, let's look at examples. Examples. HCl, that is an acid. So we're going to get used to the names hydrochloric acid. Hydrochloric what? Acid. But come also, there's a whole lot of noise there, please. Okay. An example. HCl is a hydrochloric acid. Please, I want you to listen to what I'm going to do here because I'm going to give you a few things to write for me. Now, you would notice that there is no number here on top. It's 0, basically. We'll look at that. We say it's neutral. Now, we say it's a proton donor, which means it can give away its what? Proton. And what is a proton? H+. So look at what I'm going to have. I will then have H+. So we're removing that H there. Please watch. Plus what? What are we left with? Chloride. Now, here's what I want to do. I'm just quickly going to show you here. I'll claim this one. This is a 0. Because we are separating, we are removing one thing. If we remove 1, what do you have? -1. So that would be a negative. That's just a simple math there for you to see. This is my proton. And this is my chloride ion. Remember, my proton is a hydrogen what? Ion. Done. HCl, hydrochloric acid, then gives me a proton and a chloride ion. We're going to look at another example quickly. HNO3. Again, releasing my proton, what would I have? H plus NO3. We did all of this in grade 10. The compound ion, nitrate ion. Going to write a few more. H2SO4. This one is going to be interesting. All right. Check this. It's going to release the hydrogen ion. Now, here's my question. Look at this. H2SO4. How many hydrogen ions did it release? It actually released 2 of them. So it's a 0 here. What is 0 minus 2? -2. So we are left with a sulfate what? Ion, 2 minus. Going to write so many examples for you to see. Oh, I want to write the name. Because we need to know the name. This is nitric what? Acid. This is sulfuric acid. Number 4, let's look at this. H2CO3. This is called carbonic acid. Again, we are going to remove, it's going to donate its hydrogen ion. All right. Oh, but let's balance this. We need to always balance chemistry. There's a 2 there. There's 2 hydrogens on the left. There must be 2 on the right. What will this one be? CO3, 2 what? Minus. But it's 2 hydrogens on the left and 2 hydrogens on the right. Bocamo itself, I keep muting you and you are unmuting yourself. Please, there's so much noise there. Now, lady, what's up? Phosphoric acid. Please get used to the names of these acids. It will do you well to actually check. What are we going to have here? H plus. Now, do you notice we are removing 3 of them? So it becomes what? 3 minus, but balance. All of these are acids that are donating their protons. Okay, now, lady. All of these are acids that are donating their what? Proton. So an acid is a proton donor, while a base is a proton what? Accept. Anything that accepts the H plus becomes a base. So let's look at an example of a base. Yes, Yahya?
So we call it proton because it becomes
Oh,
positive.
hold on. Let me increase the volume. Yes, talk to me.
We call it proton because it becomes positive.
No, that's the name of the hydrogen ion. An hydrogen ion is called a proton.
Oh, okay.
Hydrogen ion is called a proton.
Right.
Yep.
Okay, thank you, sir.
All right. Okay, so we have that. Let's look at an example of a base. Just look at one or two. So base that will accept. Example is ammonia. This is ammonia. So ammonia will accept what? You see, we are adding that to it. Now, what will it become? We are adding a proton. So ammonia is saying, oh, I can take a proton. We did this in term 2 when we're talking about dative covalent bond. Now, this would be NH. Now, how many hydrogens will be there? 4. But wait, hold on. It was a 0. We are now adding a 1 to it. What would it be? Plus 1. And this is called ammonium ion. When you read your notes, don't just read the formulas, get familiar with the names. So it is accepted. Another one, let's look at water. We can also add water. Water can also act as a base. What would that be? That's what? H. Now my hydrogen becomes 3. And then there's a plus there because we are adding. All right. And this is water, while this is called hydronium what? Ion. Let's look at an ion. I could have this. Chloride ion can actually be a base. Why? It can accept what? A proton. And when it accepts, what will it be? It will be HCl with no sign. Why? It was a negative 1. We're now adding a 1 to it. That gives us what? A 0. So there's no sign there. There's no number there. That's what it means. So this is a chloride ion. And this will give us hydrochloric what? Acid. So that is my first definition of what? An acid. An acid is a proton donor and a base is a proton acceptor. Are we on the same page? If something donates a hydrogen ion, that hydrogen ion is what we call a proton. Okay. So let's look at our second definition. Talk to me. Simba, your hand is up.
I already got it.
Sorry?
I already got it.
Okay. Now, Arrhenius definition. Guys, it's all about definitions today, concept. Please, once you miss this concept, you're going to miss acid and base. There's little calculation, but so many concepts. An acid is a substance that produces hydronium ions. We've mentioned that today. What's the formula for hydronium ions? H3O plus. When dissolved in water, there must be water there. Key thing is hydronium ions and the water. Let's look at examples here immediately. For example, if I have HCl plus water. Now, I wanted to see that Arrhenius was so clever. Arrhenius took the definition from Lowry Bronsted. Why do I say that? This guy is clever. I just modified it a little bit. So Arrhenius sees that what? An acid will donate what? A proton. So check what Arrhenius then did. Since it's donating, let's put this in water. It will transfer its proton there. So what are we going to have? Cl minus plus what? H3O plus. Can you see what happened? So basically, Arrhenius is saying, yes, an acid will donate a proton, but let water receive it. And when water receives that proton, then we have what? Hydronium ion. Let's look at another example. HNO3 plus H2O. So check again, it's donating a proton, but now there's water. What are we going to have? If I remove that H, what are we having? How many H did I remove? Just one. So we subtract, that gives us a negative. Plus what? Water receives it and becomes hydronium ion. So anytime I see hydronium ion, it's an acid. Whatever produces an hydronium ion is an acid. Please make sure you're catching all the definitions. And I'm emphasizing very important things and also giving you the names and the formulas. Are we on the same page? An acid is a substance that produces hydronium ion. So the key thing about acid is your hydronium what? Ions. It's either hydrogen ions or hydronium ions. I'm going to summarize when we're done. Okay, let's look at maybe two more examples. Let's look at something very nice. CH3COOH plus H2O. Yes.
Sorry, sir, please go back to the previous slide.
CH3COOH. This is your vinegar. That is your vinegar there. Okay, Michelle, you got to make it fast. Lovely. Now, what will happen here? Look at, please, my good learners, this is the hydrogen ion that will be removed. We will understand this one better in grade 12. My grade 12 know that that's organic compound. That's the hydrogen that will be removed, not the CH3 one. Okay, so what would I have here? I'm going to have CH3COO minus plus what? H3O plus. So this one gets added to that. Let's write one more. So this is ethanoic acid. We said we want to start knowing all the names. Okay, let's write one more. H2CO3 plus H2O. I want you to look at this. Now, somebody is thinking, we're going to remove the proton and we are removing 2, right? Do we add the 2 there to make it H4? No, that's a different, that doesn't even exist. So don't let's create things that don't exist. So what would this be? CO3, we are removing 2, right? So 2 minus. The formula for hydronium ion is still H3O plus. All we need to do is to balance. So let's chemistry, you don't write an equation without balancing. Let's balance this. We did balancing in grade 9, 10, and we are now in grade 11. If I put a 2 there, my hydrogen becomes what? 6. And my oxygen there becomes what? 2. So it's easy to put a 2 here. So you would see your hydrogen now, 2 times 2, 4, plus 2 to give me what? 6, which takes care of this guy, 6. Carbon is 1, we're good. What about oxygen? I have 3 here, and I have 2 here, which gives me what? 5. I have 3 here, and I have 2 there, which gives me what? 5. Okay? And all of this, I wrote the names for you. This is carbonic acid earlier on. This is carbonate ion. That's hydronium ion that we did. Let's try this. Then we'll look at a base. Now, why am I writing 2 there? What will this be? Let's remove our hydrogens. But how many hydrogens are we removing? 2. We don't put the 2 there because we cannot have H4. So we're going to have SO4, 2 minus, plus what? H3O plus. But it is not balanced. I think it follows the other one that we did. 2 there to make it 6, and 2 there. This is called sulfate ion. So you have sulfuric, which I gave you on the other page, and you have what? Hydronium ion. Guys, are we okay with the Arrhenius definitions? Examiners are going to be very specific. Yes, talk to me.
Why did you put that 3?
I put
That 3 and H3O.
Sorry, why did I put what?
3.
3.
Yeah.
That's the formula for hydronium ion.
Oh, okay.
That's where we started from. A substance that produces hydronium what? Ion. Check my definition. Hydronium ion is H3O plus.
Oh, okay.
So that's a standard. All right, let's look at the base according to Arrhenius. A substance that produces hydroxide ions. Let's get used to the names and the formulas. Hydroxide ion is OH minus when dissolved in water. Something that produces hydroxide ions. Hydroxide, so OH minus. Now, a footnote. The ions are going to be hydrated. The ions are hydrated. What does it mean? Surrounded by water molecules. Surrounded by water molecules. Example, NaOH, which is called sodium for Na. OH is hydroxide. Now, because we are saying when dissolved in water, it means we are going to have what? Water there. But what's going to happen here? This would give us Na plus what? OH minus. So these are called sodium ions, while this is known as my what? Hydroxide what? Ions. However, water molecules will be surrounding these things. These ions are hydrated. So the water only allows the NOH to break down and then surround the entire ions. I'll just do another example. And then I want us to quickly summarize what we've done. CaOH2 plus H2O. We are just, forget about the water for now. What are we going to have? Calcium is 2 plus because of group 2. And then I have OH what? Minus. Not balanced. My OH is 2 on the left, so it has to be 2 on the right. And we are done. You don't even have to show the water molecules being hydrated. We know that these are hydrated what? Ions. Which means they are surrounded with water molecules. Are we okay? Those are the first two definitions that we need to learn. Or let's do our summary at the end. We'll do all the summary of the definitions at the end. Guys, are we okay? Yes, talk to me, Ratile.
Hi, sir.
Hello.
So will I be wrong?
Okay, your network is bad. I only heard, will I be wrong? Oratile, can you please speak again?
Will I be wrong if I say a substance that produces hydroxide ions when dissociated in water?
No, you won't be wrong.
Okay, sir.
All right. Okay, quickly. Conjugate acids and base pair. So we're looking at our second concept. Conjugate acid and base pair. All right. When an acid donates a proton, so we are looking at our definition again by saying it donates a proton, it becomes a conjugate base. When an acid donates a proton, it will become, that is, whatever is left, it's a conjugate base. And this is what I mean. I'm just going to use HX to represent an acid, generally. I'll have H plus and what? X minus. So this is my acid. It has donated a proton. This one is going to be known as a conjugate what? Base. This is a common question they'll ask. Example, CH3COOH, it will donate a proton. I did this example earlier. What will it be? CH3CO minus plus what? H plus. This would be my acid. This would be my proton. And this is a conjugate what? Base. Okay, let me give you the name of this base. It's called ethanoate ions. This is ethanoic acid. We need to get used to these names. I know it's going to be a lot, but I'll keep repeating the same ones I want you to use consistently. So I have an acid. If I remove the proton, I'm left with what? A conjugate base. When a base, what will a base do? It will accept a proton. It becomes a conjugate acid. when a base accepts a proton, then it will become a conjugate acid. Example, if I have my ammonia that receives a proton, then what does it become? NH4 plus. So that is my base. Accept means we are adding. What are we adding? We're adding a proton. That is going to be a conjugate what? Acid. That will be a conjugate acid. So what will happen now is examiners are going to combine these things together, and we need to identify our conjugate acid and base pair. When I say pair, it means we're talking about two things. We are going to talk about two things. So I'm going to do one example for us and then give you a few questions to do for me. Then we move on to the next concept. So these are concept number 2. Concept number 1 was to define what acid and base is. Concept number 2 is to talk about what? Conjugate acid and base pair. All right, I will do one for us. Okay, let me do it on this page. I have HCl plus ammonia, hydrochloric acid plus ammonia. Okay, for now we're going to do this. Don't worry about that equation so much. That equation, that arrow simply means we can go forward and we can come back. Now, look at this. Cl minus plus NH4 plus. So examiner is going to tell you to identify your pair. Acid 1, acid 2. There are 2 acids in this, and there are 2 bases in this. Let's move from left to right. What do you notice here? HCl. And here it has become what? Cl. What does that tell you? It has actually lost this H. So it means it lost it by transferring there. Make sense? And when that one receives it, it becomes what? NH4 plus. So HCl lost its H plus to become what? Yeah. Now it donates. Because it donates, it is what? An acid. When an acid donates a proton, it becomes a conjugate base. So what did the HCl become? It became Cl minus. So conjugate what? Base. NH3 did receive the proton. So that means it is what? A base. But when a base accepts a proton, it becomes. So NH3 received that proton and became NH4 plus. So that is a conjugate what? Acid. So what is my acid base pair? Acid base pair. My first pair, HCl and Cl minus. HCl is an acid, Cl minus is a conjugate base. And the second one would be what? Ammonia and NH4 plus ammonium ions. I don't know if that is clear as our first example. Did that make sense? So you need to just observe what's happening, which one is losing, which one is gaining. And your definitions must just play in your head. When an acid loses, it becomes a conjugate base. Look, if we try from the other side, I want to try something with you. Look at this. If I were to focus on this side, will this still be an acid? Wait, what do you notice? NH4, right? Let's go back. NH4 became NH3. Oh, so if I was going back, do you notice that? Beautiful. Which one donates? An acid. So this guy is an acid because it donated that, right? And became what? NH3. Oh, so it's still, when an acid donates, it becomes a conjugate what? Base. This guy received, so it's a base. When a base receives, it becomes a conjugate acid. So you see, acid base still works. Okay, let's test your knowledge if you fully understood what we just did. I'm going to give you 2 or 3 activities to do for me on this, and then we'll move to our next concept. Ready for me? Thumbs up, ready for me? Okay, I am also ready for you. Identify the acid-base conjugate pair. Exercise quickly. 1, NH4 plus fluorine to give us hydrofluoric acid plus ammonia. NH3 plus H2O to give us NH4 plus OH minus hydroxide ions. Number 3, hydrochloric acid plus water to give us chloride ions. Number 4, H2SO4 plus H2O to give me HSO4 minus. All right. Let's give ourselves, I think 3 minutes should be fine. 3 minutes, 30 seconds. We will mark shortly. Yes, talk to me. Hello, Lino? We are identifying acid-base pair. Identify the acid-base pair. Too busy? Okay, let's add 2 minutes to it. Okay, guys, quickly, very fast here. What do you notice? Do you notice? Just observe. NH4 plus, compare it here. Oh, it has lost. All right. Once I notice that that has lost, basically that's what's happening. So this is going to be my acid, and whatever it becomes is the base. Now, the conjugate base. The F accepts it, becomes a base, proton acceptor, but it must become what? A conjugate what? Acid. So what's my pair one? My first pair will be what? NH4 plus and what? NH3. My second pair, let's write the acid first. What's the acid? HF and what? Oh, actually, there's a minus there. This should be F minus. Done. Look at the second one. If you make a quick comparison, NH3, NH4 plus, it has actually what? Accepted. Oh, so how is my proton being transferred? Like that. The one that accepts is a base, and it becomes a conjugate what? Acid. The one that donates is an acid, and it becomes a conjugate what? Base. So what is my pair? Let's write the acid first. H2O and what? What's the base here? Hydroxide what? Ions. What is pair number one? That's one. Sorry, pair two, which one is my acid? Ammonium ion. And what's the base? Ammonia. So please fix corrections. Number three, we just observe again. What do you notice? This one is losing to that. So this one becomes my acid. Whatever is left becomes my conjugate what? Base. Water accepts, so water is a base. Whatever it becomes a conjugate what? Acid. So what is my first pair? Let's write the acid first. HCl and what? Cl minus. What about my second pair? Let's write the acid first. Ammonium ion. And what's the base? H2O. You would notice the difference between each of them is just H. What about this one? The water becomes H3O. So the H, this one is beautiful. Look at this. 2 hydrogens. What do you have here? 1. Oh, so it's gone that way. So this is my acid. Whatever it becomes a conjugate base. Water receives, so it's a base. Whatever it becomes a conjugate what acid? So what's my first pair? H2SO4 and SO4 minus. What about my second pair? Acid first. H3O plus and what? H2O. Guys, are we okay? Can we move on? Perfect understanding here? Everybody okay? Perfect understanding? Those of you on YouTube as well, just give me a thumbs up or just type in okay. Hi, Butelezi, good evening. Okay, guys, I want to go back and just add something on my definitions. So please, I wanted to add this, and I wanted to use this one that I'm going to add. All right, so that we just get it completely right, let's define an acid as a substance that produces what? Hydronium ions. Instead of writing when dissolved in water, because sometimes there's a bit of controversy there whether it dissociates or so, please just change it and say in aqueous solution. That is more appropriate. Once I say in aqueous solution, water is involved. So that whole thing of dissociation, ionization, when you get to varsity, then we'll start specifying some will ionize and some will dissociate. So let's just stick to in aqueous what? Solution. Can we do the same thing here? Once I say in aqueous solution, it means water is there in aqueous what? Solution. So that sorts out a bit of controversies there. Okay. Lovely. So please make sure you make the change quickly as possible. All right, we are done with that. Now let's look at another concept. Like I told you, there are small concepts that we are going to keep looking at. We are going to look at proticity and ampholytes. I like looking at these two together. Proticity and ampholytes. Proticity is just telling us about the number of protons that an acid can actually give. All right, it talks about the number of protons an acid can donate. Remember, once I say acid donate, I'm trying to stress that definition for Lowry Bronsted. Now, in terms of proticity, we have 2. So number of protons. Number of protons. We have 2 types. We have what we call monoprotic acids and polyprotic acids. 11th, we are finishing acid and base as supposed to be in grade 12. Complete. Monoprotic. And from our knowledge of just common sense and general knowledge, mono means what? 1. So this is going to be an acid that donates 1 proton. An acid that donates 1 what? Proton. Example, HCl, hydrochloric acid, nitric acid, ethanoic acid, hydrofluoric. You would notice there's only one H that is donated. In fact, I know that we like colors, so let me also use colors. So the one that is donated, I'm using a different color. This is the one that is donated. So you can highlight it. Now, when I say poly, straightforward definition, what would you say? An acid that donates more than one, multiple. More than one what? Proton. An acid that donates more than one proton. And this we can look at as diprotic. If I say di, it gives me two. Okay, so an acid, we are now specific, that donates how many? Two protons. We are very specific here now. That donates two protons. Let me draw my definition, then we'll do example on the next page. Triprotic. What tri? Triangle. An acid that what? Donates three protons. And we can quickly write a few examples. I'm just going to give you one example on triprotic or level sake. So here, H2, H2, that's the idea. And then I have SO4, CO3. Here, phosphoric acid, what will it be? H3PO4. I want to use equations to show what we've done quickly. I want to use equations. Using equations. Let's see something, everybody. If I say HCl, it donates a proton. What do you notice? H plus. Now, do you notice this is 1 mole? That's what remains. Donates just one. Okay. Look at, if I were to bring in water, we did. What are we going to have? H3O plus what? You notice again, 1 more. So it only donates 1. That's what we're saying. So the number of moles is 1, 1. So this is monoprotic using an equation. Let's look at this. H2SO4. What will this give us? H plus what? But what did we say? It is not balanced. I have 2 hydrogens on the left. I need to balance it because that's chemistry. So what do I need to put in front of the hydrogen? Lovely. That's where we get our 2 moles from. Hence, making it what? Diprotic. It produces what? 2 moles. Even if I bring in water, check. H2SO4. Let's add water, make it aqueous. What would it give me? H3O plus. Now, again, we did this earlier on. It is not balanced. To balance this, I need a 2 there, I need a 2 there. Oh, beautiful. What do you notice? 2 moles. So this is diprotic. So many tiny concepts would make up the acid and base story. Are we on the same page? Okay. I want us to study something. I want to write an equation on the board. Okay, and I want us to study something very nice here. Are we ready to move on? Okay, we got to make it fast. I need to do maybe 2 more concepts today. Let me see. Yeah, let's see if we can get to do what? Ampholytes. We can get to do strong acid and weak. And then we continue from there in our next session. But let's build a foundation. Okay, can we move now? Anybody still writing? Okay, let's move. All right, now, ampholytes. But I want us to investigate something very beautiful. Ampholytes. Let's look at this. H2SO4 before we define plus H2O. And I want this thing to give me HSO4 minus plus then that HSO4 minus plus H2O, leave some space. Okay, it's fine. No, it's okay. To give me SO4 2 minus. I want us to study this together. Oh, this is beautiful. You're going to see something nice here. So HSO4 plus H2O to give me HSO4 minus plus H3O. There are 2 acids and 2 bases there. Let's see which one is the acid and which one is the base. We compare quickly. That became that. It has lost. Okay, so this becomes an acid, and this would be a conjugate what? Base. Water here received that proton. So what is water here? A base. And then that one becomes, hydronium ion becomes a conjugate what? Acid. Are we okay with the first one? Everybody okay with that first one? Just emphasis. Okay, let's look at the second one. What do you notice? SO4 minus became SO4. So we're losing this guy. All right. So this is my what? Acid. Water becomes what? A base. Now, when an acid donates a proton, it becomes what? A conjugate what? Base. And when a base accepts, it becomes a conjugate what? Now, if you look at both equations, I wanted to see something strange there. Do you notice that HSO4 minus? In the first one, it's behaving like a base. But in the second equation, it behaves as what? An acid. Wait, I want to write one more. I want to write one more. I could also have HSO4 minus plus H2O to give me H2SO4. I wanted to see something. There's an unstable behavior here. So let's number this for reference purposes. What do you notice? In the third one, do you notice that this became this? It's 1 here, but it became 2 here, which means it's receiving. Oh, beautiful. And look at water. How many hydrogens you have here? 2. How many here? 1, which means water is losing. So my proton is moving this way this time around. So HSO4 minus becomes what? A base. And then if a base accepts, it becomes a conjugate what? Acid. What about water? Water will become an acid. And OH minus becomes, okay, I want you to study something here. I want you to focus on substances that are acting as both. Look at this. Let me quickly, because of time. HSO4 minus. In that case, it was acting as a base, an acid. Okay, look at water. Water is acting as a base. Water is also acting as what? An acid. Okay, one more equation. H2O, and I know because you don't understand chemistry, you're going to be lost a bit here. Water plus water. Water from cup A plus water from cup B. What will happen? Check something. I could have H3O plus. This is called auto-ionization of water. We're going to explain all of this. Obviously, one water is, if it was not, I'll say H2O1 and H2O2, but I can't say H2O2 because that's another compound completely. But check. One of them is losing and one of them is gaining. So check. Water is acting as an acid, yet water is also acting as what? A base. So there are certain substances that act as both acids and bases. Those substances are called ampholytes. So that's the investigation that we did. Ampholytes are substances that can act as both what? Acids and bases. An ampholyte. And I want to give you examples. Already from this page, I can identify 2. Water is a common example, but I want to show you how to quickly look at my examples. So, example, I have what? Water. Please, I want you to be smart about this. I'm going to look at my polyprotic acid. We mentioned that earlier on. Please look up, everybody. Let me do this in different boxes. Can you write a bit small? I'm going to do 3 examples and quickly identify. One example of my polyprotic acid is H2SO4. Remember, it can donate what? 2. But here's the deal I want to show you. Let's remove the 2 step by step. So step 1, let's remove 1. What will I have? HSO4 minus. Can I remove another one? What will I have? SO4 2 minus. Remember, it was 0 at first. We subtract 1 minus 1. Now minus 1 minus 1 would give us what? Minus 2. Please look at the procedure. If I look at the center one is going to be my focus. Do you notice that if I remove H from here, it becomes this? If I add H, it becomes that. Wait, by removing, it's acting as an acid. By adding H, it becomes a base. So my ampholyte is that. In case I lost you, I'm going to find you with another example. It can donate more than 1 carbonic acid, H2CO3. Let's remove it step by step. What are we going to have? Remove the first one. What do we have? HCO3. There has to be a minus because we've removed 1. Now let's remove the second one. It's a minus 1 already. We removed the hydrogen. CO3, 2 minus. The middle one is an ampholyte. Why? When it loses, it goes down. When it gains, it goes up. Huh? When we add, it becomes a base. Are we okay, everybody? Let me put arrows here for you to see something. Here, minus H plus, which is an acid. Here, plus H plus, to make you see. If it goes down, it's acting as an acid. When it goes up, it's acting as a base. Okay, let's look at this. H3PO4. How many protons will it lose? 3. But can we do it step by step? What's the first one? H2PO4 minus. Can we go down again by losing the next one? What would it be? H. Now it's minus 1. Let's subtract 1 again. Becomes what? 2 minus. Now let's subtract the third one. What are we going to have? PO4, 3 minus. The two that are in the middle are ampholytes. Because when they go down, they are losing. And this, when it goes up, it is gaining. HPO4, 2 minus. I want to give you a quick homework. Find the names of all these ions for me. Huh? Yeah. Google. It's okay. That's learning now. Google it. ChatGPT it. Okay. But I just want to I want you to commit to also learning. We need to know the names and the formulas. Guys, are we good? We need to look at one more concept for today, finishing at past. Are we okay, everybody? The last concept for today. So, like I told you, it's small concepts that make up the big one. All right. Strong strengths of acid and base. Strength of acids and bases. We are going to start from acid. An acid could either be strong or weak. Strong acid. An acid that ionizes in water to produce a high concentration. Oh, sorry. There's a word I missed. Sorry. In water completely. Almost completely. To produce a high concentration of hydronium ions. I'm going to write some things and I'm going to put a star to it. Keep this note for next year, but I'm going to put a star on something you'll only understand in grade 12. But I want us to quickly, I'll mention it next week, just in passing. And how do we represent it? Look, it has a high concentration. What do we mean? It means, okay, guys, when we write brackets like this, bracket like this means concentration. Let's quickly put that there. That is the concentration. So we're saying the concentration of the hydronium ion will be greater than the concentration of the acid itself. It produces, how do you know a good school? A good school is a school that produces what? High number of learners who get what? Bachelor's degree. That's what we're saying. All right? So it produces a high concentration of hydronium ions. Number two, which I want us to, which I would explain later, Ka is greater than 1. Ka means equilibrium constants. Only grade 12 will understand this for now. But next year when we do it, you say, oh, that's what you mean. Equilibrium constant of acid is greater than 1. Then I'll write the next one. X plus H2O, H3O plus X minus. Please, I'm going to put a star on these two. Let's put grade 12 and grade 12 on it. There are some topics that we do, then you'll come back to, this is what this guy was saying. So we just put grade 12 there. Oh, by the way, common examples. Common, we need those. Let me do something. Let me use a table for my examples. I put the 4. Okay. What is a weak acid? Trying to run time. An acid that ionizes partially, that's the key word, in water or aqueous solution, AQU. Okay. To produce a low concentration of. Now, do you notice that acids are associated with hydronium ions? Every time we say acid, we talk about what? Hydronium ions. Here, we are saying the concentration is so small, it is less than the concentration of the acid itself. Ka would be less than 1. Now you know Ka is equilibrium constant grade 12. And our equation will be Hx. Don't worry about this equation that much, but my grade 12s should know what I mean. The arrows are not mistakes, so don't try to correct it. One is longer than the other. Wait, let me do this like this. I want the reverse, the one going back to be longer. The arrows are not mistakes. Okay. An acid that ionizes partially. So you would see one is completely, the other one is what? Partially. The one that is complete will produce a high concentration of hydronium ions. Okay. All right. Are we good? My last slide would be to look at just common examples that we need to know. All right, guys, let's look at strong base and a weak base as quickly as possible. I only have 6 minutes left. What is a strong base? It is a base that dissociates, again, because it's strong, it will what? Completely. Now, it will not dissociate except it finds itself in water or in aqueous what? Solution. And when it does that, it produces a high concentration hydroxide what? Ions. Again, you would notice bases are associated with hydroxide ions. acids are associated with hydronium ions. What are we saying here? The concentration of the hydroxide ion will be greater than the concentration of the base. The equilibrium constant of a base, Kb, will be greater than 1. All right? And XH, that's my base. Okay, let me write XOH here for the base. We can actually use that. X is a metal. Okay? Will give me plus H2O, would ionize to give me X plus. Forward reaction is favored, and the reverse reaction is very small, H minus. A weak base, we're just switching things around if you notice. A base that dissociates. Now, what would this be? Partially in an aqueous what? Solution, which is basically with water, to produce a low concentration. So if it's partial, it's going to be low. And if it's a base, it's going to be what? Hydroxide what? Ions. So the hydroxide ions, which makes it a base, is actually very small compared to the base itself. What can you tell me about Kb? It will definitely be less than. Can you see it's just the same rigor round? XOH plus H2O X plus OH minus. Okay. Now we end by just writing a few examples. So we're going to use a table to make life very easy for us, and I'll only be writing common examples. Are we ready? Okay, common examples quickly. So we're just going to do that. Strong acid, weak acid, strong base, and weak base. 2 minutes maximum, we should be done. Please note the names. Hydrochloric acid, I gave you the name of that one earlier. Nitric acid, I gave you the name of that one earlier. Weak acid, okay, no. Strong acid, common examples. Sulfuric acid. Weak acids, I would have my carbonic acid. This is what you find in your cold drink when they say carbonated drinks. Okay. Anything that has a COOH, that's your vinegar, that's a weak acid. Your strong base, we go to group 1 and group 2. So I should be talking about common examples: my sodium hydroxide, my potassium hydroxide, my calcium hydroxide, my magnesium hydroxide. The 2 is because they are in group 2. My weak bases would be ammonia, sodium carbonate. Anything that has to do with a carbonate would be weak. Sodium hydrogen carbonate, weak. Oh, sorry, this is Na2CO3. Calcium carbonate, weak. Okay, barium hydroxide, weak. These are common examples that I need us to know. It's very important that we should know them, please. These are the ones examiners are going to use. If you don't know this, it's going to catch us somewhere. It's going to catch us somewhere very big. So we have your, let me add this one to it. This one to it, hydrobromic acid. Hydrobromic from hydrochloric. Okay. I just want to stick to these examples. I don't want to give you so much more. There are a lot more, but this is just fine for us. Okay, guys, we're good. So we'll end it here. Uncommon examples of acid and base. So please look at the things we looked at today. We define acid and base, two definitions. We looked at what again? Conjugate acid and base. What else did we look at? Proticity. Talked about monoprotic and diprotic and triprotic. What else? Ampholytes. Conjugate acid and base pair. Strong acid. Oh, we looked at about 6 or 7 concepts, which is quite good. All right. Anyway, guys, let's catch up in our lesson 2, where we now go deeper. We start going into calculations gradually. By the 3rd lesson, you become pros with acid and base. Have a lovely evening, everybody. Yes, Lino? Lino, you raised your hand. Okay, take a screenshot. So carbonates are generally weak. That's what we're saying. Anytime I see a carbonate, whether acid or base, they are considered weak. All right. Good night, everybody, and catch you next week for acid and base number 2.